Now we have questions related to the log function. The log x function, as we've seen previously, or as we've said previously, is inverse to y equals 10 to the x. The log log is inverse to the 10 to the x function. Now you're given this fact and you're asked to find the log of 0.01, 100, 10 million, okay? Let's review what you do, because you might not immediately see this, but here's what I would expect you to do based on understanding everything that we've done so far. You would take the 10 to the x table, which you can easily make, and you would invert it to get the log table. So our 10 to the x table is easy enough. 10 to the 1, 10 to the 0 is 1, 10 to the 1 is 10, 10 to the second is 100. Everybody got that, but people had trouble doing these because they don't know the laws of exponents. And this is something that was done almost 3 months ago. You were assigned to be able to do the graph of 2 to the x based on a table with some negative values in the table. And how do you get the value of 2 to the negative 2? You have to know that 2 to the negative 2 means 1 over 2 squared. So you have to know, and if you knew that, and if you had internalized that and understood the laws of exponents when you were asked to, just chiding you a little bit because I know human nature, then you'd know that 10 to the negative 1 means 1 over 10 to the 1. Of course, 1 over 10 to the 1 is 1 over 10, 10 to the 1 is 10. And that's then 0.1, and we know how to do that. And the 10 to the negative 2 is 1 over 10 squared, which is 1 over 100, which is 0.01. So we get these numbers, and now we can invert our table and maybe draw a graph. And we've done this already for some other log functions. Log to the base 3, log to the base 2, log to the base e. For the base 10 function, this would be our table, just flipping the columns. And everybody knows to flip these columns, and that's good. So, to get the log of 0.01, we can just read it off the table. This is x, this is log x. So log of 0.01 is negative 2, and log of 100 is 2. So we get those, but let's write out why that's true. Log of 100 is the log of 10 squared, because 100 is 10 squared, and the log function is inverse to the 10 to the x function. So the log of 10 squared, these being inverse functions, is just 2. Just like the log of 10 to the negative 2. The log of the 10 to the power function, the log and the 10 to the power function cancel each other out essentially. They're inverse functions, and we just get negative 2. And this is because the log of 10 to the x, that's a composite. That's f of g of x for inverse functions. And if you understand what we did with inverse functions and doing the composites, at the end, we just get x. When we do f of g of x and we always get x, and then do g of f of x and always get x, that means f and g are inverses. Well, this is f of g of x, where g of x is 10 to the x and f of x is log x. We've defined the log to be the inverse of this function. So we're doing a composite of inverse functions. So this has to equal x for any number x. So the log of 10 squared has to equal 2. The log of 10 to the negative 2 has to equal negative 2. And the log of 10 million, what's that? Well, you can see easily that this is 10 to the 7th power, because we know how to do powers of 10, I hope. And I think we do. Well, log of 10 to the 7th has to be 7, doesn't it? So, from the pattern we see here, we could also imagine extending this table. Okay? first extend this table, every time we go to 3, 4, 5, 6, every time we go to another number, we get an extra 0 here, don't we? Which means every time the log of x goes to a bigger number, the x is going to have to become 10 times as great and get an extra 0. So we can visualize where this number would appear on this table, just a few more lines down. 5 more lines and we would have this number. 5 more lines in this table inverted to this table. You want to understand that.